Hello students, welcome to Distinction Learning Platform, and in this video we're talking about blood pressure. Okay, and before we begin our lesson, make sure that in the comment section you comment as well as you like the video, and on top of that you find a link in the comment section so that it will take you to the website where you find now other educational videos. Now, to make the story short, let us start learning about blood pressure. What is blood pressure? Blood pressure, basically, we talk about the force or the pressure exerted on the what? On the blood vessel walls. Okay? So let us try to write that one so that we illustrate whatever we're talking about. What is this blood pressure? So blood pressure, we're saying, is the force or pressure exerted on the blood vessel walls. Okay, so what is again blood pressure? We're just saying it's the force or pressure exerted on the blood vessel walls. So let us give a scenario on that. If we have this blood vessel and this is the flow of blood, okay, and this blood that is flowing in the blood vessels, it has that ability to give pressure against the walls of those blood vessels. So this flow of blood, it has that ability to exert certain pressure on the walls of these blood vessels, and that pressure, if we try to measure it, basically now that is what we call blood pressure. Now, this pressure can happen on two important occasions. Okay, what are those two important occasions? The pressure that we can measure after the heart contracts is what we call systolic blood pressure, and the pressure that we can measure after the heart relaxes, that's what we call diastolic blood pressure. So let us write that important point. So we are saying this pressure that we are measuring, meaning that the force that is being exerted against the wall of the different blood vessels is what we call blood pressure. Now that pressure can happen on two important occasions. The first one is what? During the heart contraction, and the second one is during heart relaxation. So what we simply mean is that this can happen on two different occasions. During what? Heart contraction. Okay, let's just say C, heart contraction, but we don't just say heart contraction, then we call it what we call a systole. Okay, so this can happen under systole. Okay, it is S, and it can also happen during relaxation, but we don't call it relaxation, we're going to call it diastole. Okay, it is D, diastole. Okay, now we're going to categorize this one. So during heart contraction, which is systole, what type of pressure is that? We call it systolic blood pressure. So no wonder we're going to finish this one as systolic blood pressure. Systolic blood pressure. During relaxation, if the ventricles are relaxed, then the type of pressure that we're going to find in those veins or arteries is what we call diastolic blood pressure. Okay, diastolic blood pressure, like that. Okay. Now, no wonder if you look at the presentation of blood pressure, it is shown like this. So if you look at the blood pressure, the way the blood pressure is presented is nothing but equal to, we say, systolic blood pressure on top over diastolic blood pressure, like that. Okay, and you need to know how you can represent blood pressure. So we're saying blood pressure can be represented as systolic blood pressure over diastolic blood pressure. Again, what is systolic blood pressure? It's a type of blood pressure that is measured after ventricular systole or after ventricular contraction. What about diastolic blood pressure? It's a type of blood pressure that is measured after ventricular relaxation or ventricular diastole. It is very, very simple. Now, you are busy asking to say what are the numbers or normal ranges of systolic blood pressure as well as diastolic blood pressure. So the numbers that you can simply remember is this one. blood pressure is nothing but equal to systolic blood pressure. Basically, the normal range starts from 90 to 120. Okay, millimeter of mercury. That's a normal range of systolic blood pressure. But for diastolic blood pressure, it has to be less than 80. Okay, that is the normal range for systolic blood pressure as well as diastolic blood pressure. Okay, so this is the basic introduction of blood pressure. Now, let us look at some important things or formulas that you need to know about blood pressure. So we'll talk about here the formulas. The next tip, we'll talk about the blood pressure regulation, which is a vital part of this lecture. Okay? So let us talk about the formulas that describe the blood pressure. Okay, like this. So this one is a clinical presentation of blood pressure. It's not a formula, but on how we can find out the blood pressure. Now is when this is when you can use the formulas. How can you calculate the blood pressure? So blood pressure, it is given by a certain formula, which is this one. Blood pressure is nothing but equal to, we say, cardiac output times systemic vascular resistance. Okay, cardiac output times the systemic vascular resistance. That is what the formula for blood pressure. Make sure you need to understand about this. Blood pressure equals to cardiac output times systemic vascular resistance. So what this simply means is that blood pressure is directly proportional to cardiac output as well as the systemic vascular resistance. Systemic vascular resistance, sometimes it is called total peripheral resistance. That's the same thing. So if you see total peripheral resistance and the systemic vascular resistance, basically these are the same terminology that they use. Okay? So meaning that if we try to increase the cardiac output here, so let me just give a scenario. If we increase the cardiac output from here, basically they are also going to increase the blood pressure. Why? Because they are direct proportion to one another. Same applies to systemic vascular resistance. If we increase the systemic vascular resistance, basically it also increases the cardiac output, as well as vice versa. Which simply means that if you decrease the cardiac output, also the blood pressure is going to be decreased. Then, if you decrease the systemic vascular resistance or the total peripheral resistance, also decreases the blood pressure. So now, the next important thing that we need to understand is what is this cardiac output that I'm talking about? What is this systemic vascular resistance that I'm talking about? So if we understand those factors, basically it will be very, very easy to understand about all the blood pressure, more especially on the blood pressure regulation. Okay, so let us understand about this cardiac output, this one. So this is what we call cardiac output. So let us write it. So let us understand about the cardiac output. Okay. So what is cardiac output? So cardiac output basically talks about the volume or the amount of blood that is ejected from the heart per minute. Okay, what is cardiac output again? It's the volume of blood ejected from the heart per minute. Okay, that is what we call cardiac output. So, but to know the number of or the amount of the cardiac output calculation, you need to know the formula for cardiac output. Since we know the definition to say it is the volume of blood ejected from the heart after 1 minute. So, but we need to know the formula. What is the formula of this cardiac output? So, cardiac output equals to heart rate times stroke volume, SV. So SV stands for stroke volume. Okay, so cardiac output is nothing but equal to, you get the heart rate multiplied by the stroke volume. I'll explain about that. Okay, that's what we call cardiac output. Now, So since if you get the heart rate, we know that the normal heart rate in the normal average heart rate in our body is about 72 beats per minute, okay? And the stroke volume is about 70. If you multiply, then you're going to get the average cardiac output, which is about maybe 5 liters per minute, okay? Now, we need to understand this one, this heart rate. Since we've understood the cardiac output, which is the volume, you get it from the heart per minute. Now, it depends on heart rate as well as the stroke volume. So, now let's talk about the heart rate, okay? Heart rate. So, heart rate basically, we are just talking about the number of beats, the number of heartbeats produced per minute. Per minute, that's what we call heart rate, okay? The number of heartbeats per minute, that's what we call heart rate. And this heart rate is going to depend on various factors again. There are a lot of things that you need to take note here, okay? This heart rate is going to depend on two important factors, okay? The sympathetic nervous system as well as the parasympathetic nervous system. So heart rate mostly is going to depend on the nervous system, either the sympathetic nervous system or the parasympathetic nervous system, okay? And if you look at the sympathetic nervous system, it likes to increase the heart rate. So what are we simply saying here? So if you stimulate the sympathetic nervous system, it's going to increase the heart rate, okay? Then if you stimulate the parasympathetic nervous system, it's going to decrease the heart rate. So these are the important factors that you need to know about the heart rate. Make sure that you understand on that, okay? Next, let's understand about the stroke volume, SV. SV. So SV stands for stroke volume. Stroke volume, which is this one. Stroke volume. That's what we call SV, okay? Now, what is this stroke volume? Just from the word volume, basically, it is the amount of blood or the volume that's going to be produced from the heart per beat. So this one is per beat. Amount of volume that is produced by the heart per beat. Cardiac output, we said per minute. Amount of volume produced by the heart or from the heart per minute. But stroke volume, it has to be per beat, okay? Now, this stroke volume also, it will depend on various factors, but stroke volume depends on three important factors that you need to know, okay? What are those three important factors? We'll start with what we call preload, okay? Preload, I'll explain on that one. It also depends on contractility, okay? Now, it also depends on what we call afterload. All right? So, what is this preload? So, preload basically, we're just talking about the amount of blood that is going to be present in the ventricles, okay? So, we're saying preload is the amount of blood that's going to be present in the what? Ventricles. After the ventricles have completely relaxed. Then if you try to measure the amount of blood there, then that's what we call preload. Okay? Preload, again, what is it? Preload, this is just amount of blood that is present in the ventricles after the heart has completely relaxed. Then that's what we call preload. Okay? And preload depends on something which we call, it depends on what we call, if you remember about the Frank-Starling law. Okay? So preload basically depends on this law, which is Frank-Starling law. And it states that if you are going to have a lot of blood in the ventricles before contraction, basically the heart muscles are going to be stretched. If they stretch enough, the heart muscles, they are going to have that strength so that now that preload or the amount of blood present in the ventricles can be now pumped out of the heart, a lot of it. That's what we call the Frank-Starling law. So meaning that from that definition, basically, we know that if we increase the preload, basically we are going to increase the SV. So which we mean to say, if you increase the preload, then you're going to increase the what? So increase the preload, you're going to increase the SV. Okay? Stroke volume. So make sure that you understand. What about contractility? So contractility basically is just talking about the how much the heart muscles are contracting. So if the heart muscles are contracting at a faster rate, quite alright, you're going to increase the stroke volume. Okay, so that's what we call contractility. Nothing like difficult to understand from this. That's how much the heart is contracting. Is the heart contracting slowly, or is the heart contracting faster? So if the heart is contracting faster, basically you are increasing the stroke volume. If it is contracting slowly, it's easy. Now you are decreasing the stroke volume. Okay, but the most important factor is this one that you need to understand: after load. So after load, what is that? Okay, what is that after load? So after load basically simply means that is the amount of force that the heart has to overcome in order to pump blood out of the heart. Okay, so after load, we're just talking about the resistance. So after load, we're just talking about resistance to blood flow. Okay, so resistance to blood flow. So that's what we call afterload. So mean that if you increase the afterload, what does it mean? You're increasing the resistance to blood flow. Okay, so if the heart tries to pump out enough blood, then there is much resistance in the blood vessels. So meaning that if you increase the resistance to the blood flow, what do you think to the stroke volume? The stroke volume is going to decrease. So in simpler terms, what you need to remember is that after load, if you increase it, you're going to decrease the stroke volume. So here, the important notice that you need to remember is that if you increase the after load, so you say after load, like that AL, after load, you're decreasing the stroke volume. That is the only factor that is inversely proportional. Okay? So these are the important factors that you need to understand about the cardiac output. Okay, now the other important factor that you need to understand is this one. Since we've understood about the cardiac output and its factors, which is the heart rate, stroke volume, then you go to systemic vesicular resistance. Then we are done. So let us understand about the systemic vesicular resistance. Systemic vesicular resistance, also called total peripheral resistance. Okay, this one. Let us understand about it. Okay, so total peripheral resistance, or the systemic vesicular resistance. So that one, basically, we're just talking about the resistance of what? The blood flow. Okay, that's what we call total peripheral resistance. So that the resistance provided by various factors, either maybe the diameter of the blood vessels, or maybe the thickness of the blood vessels, like that. Any factor contributing to that is going to be increasing the total peripheral resistance, or the systemic vesicular resistance. So in simpler terms, what is SVR, or systemic vesicular resistance? We're talking about the resistance to the blood flow provided by different factors. Okay, so what are those factors? But I'm going to tell you the important factors that you need to remember according to this law. Okay, so the important factor that you need to remember here is about this person. So this person postulated something. Okay, Pausani's law. Okay, so this person postulated something, or talked about the resistance to blood flow, the relationship of the blood flow with maybe the diameter of the blood vessels, as well as the viscosity and also the length of the blood vessels. So let us talk about this. So this person said the resistance, so let us use black. So the resistance of this to the blood flow is nothing but equal to, okay, the viscosity, okay, viscosity multiplied by what? The length of the blood vessel over the radius to the power 4. Okay, so this is what is said. Okay, now the important factor, I need you to understand about this important factor. Okay, this one. So as you can see, if you can look at the radius and also the resistance, what is the relationship between radius and resistance? So it is, so resistance and radius, they are inversely proportional to one another. So it simply means that if you increase the resistance, basically you're going to decrease the radius. Okay, if you decrease the radius, mean that you are increasing the resistance, like that, and vice versa. If you decrease the resistance, basically meaning that the radius has been increased, like that. So this is what we call inversely proportional to one another. And the question that you can ask is that, what is this radius? It is the radius of the what? It is the radius of the blood vessels. If you look at the blood vessel like this is the blood vessel, okay, and this is the diameter of the blood vessel. Now, half of that diameter is what we call radius, okay? So it simply means that if you reduce this diameter, basically you are going to increase resistance, which is very bad, because if you increase the resistance, you are increasing the blood pressure. So we'll talk about now the importance factors, the importance of increasing the systemic vesicular resistance, as well as the importance of increasing the cardiac output. We'll talk about that under blood pressure regulation. Okay, so these are the important things that you need to remember. And the last important things that you need to remember is this one. Okay, the pulse pressure. So I can use black for this one. So pulse pressure, but here we'll just talk about the formula. The pulse pressure, basically you just get systolic blood pressure minus, you subtract with diastolic blood pressure. Okay, that's what we call pulse pressure. So if you want to find out the pulse pressure of someone, basically you need to get the systolic blood pressure, then you subtract with the diastolic blood pressure. The last important thing that you need to understand now, which is now the mean arterial pressure. This is a very important pressure that you need to understand. Mean arterial pressure, okay, which is sometimes written as MAP. Okay, so MAP, or mean arterial pressure or blood pressure, what does that mean? So mean arterial blood pressure, basically we talk about the average blood pressure that is required to make sure that there is adequate tissue perfusion. So MAP, in simple terms, is a pressure that is used to determine if the body tissues are receiving enough blood or no. So they use what we call mean arterial pressure. How do you get the mean arterial pressure again? So mean arterial pressure is very simple. You just get diastolic blood pressure, okay, multiplied by 1/3 of this one, which is the pulse pressure, multiplied by what? The pulse pressure. Let's just say PP. So this is how you can find the mean arterial pressure. What is the importance of mean arterial pressure? To determine tissue perfusion. Okay, so these are the important things that you need to understand. Make sure that you take note of all the factors that I've talked about. Okay, now let's talk about how the body can regulate the blood pressure, because if you have high blood pressure, the body has to maintain the normal range of blood pressure, because if you have high blood pressure, it can have like important and dangerous consequences or complications. you can have maybe it can result to heart failure, maybe kidney problem, liver problems, the brain problems like that. So if the body doesn't want the body to go into those complications, so the body will try by all means to regulate the blood pressure. So what we'll do is we'll start with what happens in the body if someone is having low blood pressure. Low blood pressure, okay? What's going to happen to that, okay? I'm going to make space here. Okay, so what's going to happen is that under low blood pressure, so we'll talk about under low blood pressure as well as the under high blood pressure. So under low blood pressure, now the body is going to respond in three important ways. The first way is this immediate response. The second way is intermediate response, and the last way is long-term response. You need to understand, okay? Again, so let us make something here. This. So you need to take note of this. So blood pressure regulation depends on what? Three important factors. Although immediate response will be because of who? The nervous system. So let's just say AS. The first important factor that you need to understand is that the body, if it wants to regulate the blood pressure, it has to depend on the first important thing, which is nervous system, either parasympathetic nervous system or sympathetic nervous system. Okay, the second important factor, it will depend now on local hormones. So it will depend on hormones. Okay, and the third one, it will depend on what? The renal system. Okay, renal system. So remember, first one is what? The nervous system. Second one, hormonal system. Third one is what? The renal system. You need to take note of that. Now let us start with the first one. Okay, under low blood pressure. Okay, so low blood pressure, basically we are going to have low systolic blood pressure, which is less than now 90, like that. Okay, then if someone is having low blood pressure, okay, so I'm just saying here the systolic blood pressure is less than what? 90. Then you are worried to say this is low blood pressure. Okay, most you worry about the systolic blood pressure. Okay, then what is the first thing that the body is going to do? So immediate response. So immediate response is going to happen in just seconds to, so this is a very fast response, 2 minutes. Okay, so immediate response means that this response, as long as the body has detected that there is low blood pressure, then there will be immediate response that will happen in what? Seconds to minutes. Okay, so what is that now? Remember, immediate response is going to use the nervous system. Okay, so this one is going to use the nervous system. Nervous system is going to use this one. Now we need to understand something here. So now the question that you can ask is that how does it activate the nervous system? How does the body know that okay, there is low blood pressure? Okay, so that now we can activate the nervous system. How? So that question to be answered is that in the body we have certain sensors that detect that there is low blood pressure. Okay, if you look at the carotid arteries there, on the bifurcation into the internal carotid artery and the external carotid artery, from there is that on the bifurcation there is what we call carotid sinus. Okay, so we're saying carotid sinuses, these are the ones that are going to detect low blood pressure. Okay, so let us write that. So carotid sinus, they are going to be what? Activated like that. They are going to sense that there is what? Low blood pressure. Now what are these going to do? Now they will start sending stimulation to the what? To the medulla oblongata or to the central nervous system. So what we're saying is that the low blood pressure, okay, is going to activate the carotid sinuses. Okay, these carotid sinuses, then they are going to send information where? To the central nervous system or to the nervous system. Okay, So this one is going to send information where? To the nervous system. Okay. Basically, if you be more specific in the nervous system, basically central nervous system, if you want to be more specific, it will send information to the medulla oblongata. Medulla, let's say oblongata like that. Okay. So carotid sinus has been activated. Okay, where can you find the carotid sinus? On the bifurcation there, okay, between the external and internal carotid artery. There now, if these carotid sinuses are being activated, they will send now information to the medulla oblongata. So that now, the nervous system, now what part of nervous system is going to be activated? Now, the sympathetic, here, sympathetic nervous system. Okay, sympathetic nervous system is the one that's going to be activated. Okay, and this sympathetic nervous system, since it is activated, it will start now producing some certain mediators. Okay, so it will start producing some certain mediators, which we call norepinephrine and as well as epinephrine. Okay, epinephrine and as well as norepinephrine. Again, we go back. Nervous system, we come back here. So if there is low blood pressure, okay, the carotid sinuses are going to be what? Activated and send information to the nervous system to say there is low blood pressure. But in the nervous system, specifically, we are saying in the medulla oblongata. The medulla oblongata now will start sending information basically via the sympathetic nervous system. This sympathetic nervous system, it has some chemical mediators which we call the norepinephrine and epinephrine that will start doing now the work so that it can increase the blood pressure. Okay, because we have low blood pressure, and the goal is to make sure that the blood pressure starts increasing so that it can go back to the normal ranges. Okay, so now let's talk about the effect of norepinephrine and epinephrine. So the effect of these two important hormones or chemical mediators, if you have this blood vessel, okay, if you have this blood vessel, so first important thing is they can act on the blood vessels. Okay, if this is a blood vessel, they'll start like squeezing the blood vessel. So what they do is, if this is no epinephrine, if it binds to these blood vessels, basically they're going to make sure that they constrict these blood vessels. As you can see, the diameter there, the diameter is reduced because of these two important factors. If that happens, remember now, if you go back to the formulas that we talked about, okay, if you look at the diameter there, the radius has been reduced. If you go back, what is the formula that was relating to the radius? Okay, it is what? This law, Poisson's law, which is this one. And this one talks about what? Systemic vascular resistance. So meaning that if you reduce the diameter of this blood vessel, basically you are increasing the systemic vascular resistance. So what are we doing if we do this? What we are doing is we are increasing the systemic vascular resistance. Okay, increasing the systemic vascular resistance. Reason being, we said to say from here, according to this law, we said if we increase, if we decrease the radius or the diameter, basically we are increasing the resistance. With the resistance, the systemic vascular resistance. Now, how does the systemic vascular resistance relate with the blood pressure? The systemic vascular resistance and the blood pressure, they are direct proportion to one another. So if we increase the systemic vascular resistance, we are increasing the what? The blood pressure. So what did we say? The goal here is to make sure that the blood pressure starts increasing because we have low blood pressure initially. Okay, that's the first important thing that the body is going to do. The next thing, so this they do a lot of things. Apart from acting on the blood vessels, they're going to start acting on the heart. Okay, So if this is the heart, so let's say if this is the heart, okay, this is the heart, and these two important chemicals, they can come on the heart here, okay, and stimulate the heart there, so that now they can increase the heart rate, okay. So what they do here is that they are going to increase the heart rate, okay. So the result of acting on the heart is to increase the heart rate, okay. But if you increase the heart rate, what did we say? You are going to increase the cardiac output, because if you come here, heart rate, if you increase the heart rate, you increase the cardiac output, okay. So if you increase the heart rate here, you're going to increase the cardiac output, and if you increase the cardiac output, you are increasing the blood pressure, okay. You need to understand on that. So that's what will happen in just 6 seconds to minutes. So those are the mechanism that can happen. You need to know the physiology of this. Okay, now we go to another part. So if you understand this one now, we can go to intermediate response. Let us make a space here. Okay, so intermediate response. So what are the intermediate response? So intermediate response now is because of, what did I say? Because of local hormones. So here now is because of what? The hormones that are produced. But apart from hormones, as well as the fluid, depend on, as well as only fluid. Okay? Fluids. Pressure. Fluid pressure. Okay? So we'll talk about the fluid pressure there. Okay? So on the intermediate response, basically, it's going to depend on 2 important factors, which is the hormones and the fluid pressure. Now, here, since we talked about here, it happens in second to minute, but this one, it will happen in now minutes to hours. Okay? Take note of that. So minutes to hours. Now, what's going to happen here? So if there's low blood pressure, remember that the important stimuli here is low blood pressure. Okay, low blood pressure, what is it going to do? Okay, low blood pressure now is going to do something to the heart. Okay, so this is the heart. Okay, so low blood pressure can simply activate something in the heart. Okay, in the heart we've got important hormones that helps to regulate blood pressure. So we've got what we call ANP. Okay, ANP stands for what? Atrial natriuretic peptide. Atrial natriuretic peptide. So, and ANP basically is the hormone that is found in the atrium, and it is only produced if the heart muscles are being stretched, or if the atrium is being stretched because of the pressure. But if you look at the low blood pressure doesn't stretch much of the atrium of the heart. So meaning that there will be no production or decreased production of what? ANP. Okay. So what do we mean? So what we mean here, this hormone is going to be what? Reduced. So there will be decreased production of what? ANP. Okay. If there is decreased production of ANP, what would be the result now? Okay. Then the result for this one is ANP is going to act on the what? The renal system there. Okay. It's going to act on the renal system. So ANP now is going to stimulate. Now, if there is no ANP, then there will be renal system stimulation. Okay, or the kidneys will be stimulated. The renal system will be what? Stimulated. If the renal system is stimulated, meaning that there will be absorption of what? Water. Okay, and sodium as well. So what are we saying? If the renal system is what? Activated, because there is low production of ANP, basically we are going to increase the reabsorption of what? Fluid. So let's just say the absorption of fluid into what? The blood. Okay. So the absorption of fluid into blood, and the result for this one basically, so let's just say here the result for that one is now is going to increase now the blood pressure. Okay, because if the kidneys are reabsorbing much of the fluid back into the bloodstream, the blood pressure now is going to increase. Reason being because if you are reabsorbing much of the fluid back into the bloodstream, they will be increasing the preload. Preload, they will be increasing the stroke volume. Increasing the stroke volume, now they will increase in the what? Blood pressure. Okay. Another important thing that happens here. Okay, last thing that's going to happen here. Okay, so here again, apart from this important factor here, okay, there is also another one which I'm going to write here, number 2. Okay, another important is what? Decrease in, so decrease in blood pressure also is going to stimulate something. Okay, so decrease in blood pressure, basically you're going to have decrease in hydrostatic pressure. Okay, so decrease in blood pressure, basically there will be decrease in hydrostatic pressure. If you remember about the physiology of fluid or the plasma there, if you look at the hydrostatic pressure, so hydrostatic pressure is the pressure that is exerted by the fluid plasma, and that pressure likes to make sure that the fluid moves out of the blood vessels. Now here there is decrease in hydrostatic pressure. What do you think is going to happen? So this decrease in hydrostatic pressure will stimulate something. Okay, will stimulate now the fluid from the interstitial fluid there to start going into the what? Into the blood vessels. So if you decrease the hydrostatic pressure, you are going to increase the another important pressure which we call oncotic pressure. Okay, and this oncotic pressure basically is going to increase the blood pressure. Okay, so that's what we mean. So again, to go back again, we're saying another important stimuli is that if there is no blood pressure, it's going to make sure that hydrostatic pressure drops. Now if hydrostatic pressure drops, there will be increase in oncotic pressure, or the pressure that likes the fluid to start going into the bloodstream, and that's what we need. If now there is a lot of blood, there is a lot of fluid into the blood vessels, now they will be increasing the what? Blood pressure. So these are the two important mechanisms that you need to understand. Okay. So now let's go to the last part here, which is the long-term response. Okay. Long-term response. So here, if this is minutes to hours, long-term response, it will be now minutes to days. So this response is minutes to days. I mean hours to days. Hours to days. Okay, that will be now the long-term response. It takes longer. Okay, this one. Now, remember what I said is that long-term response is only provided by the what? The kidney system or the renal system. Okay, it's provided by the renal system. Now, let us look at what can happen here. So remember again, what is the stimuli? It is low blood pressure. Low blood pressure. That is the stimuli. If there is low blood pressure, you need to understand here something. Low blood pressure where? Now to the kidneys. There is low blood pressure to the kidneys. What's going to happen? The kidneys, they are going to be activated and they start producing what? Certain hormones. So low blood pressure to the kidneys causes what? Production of what? Renin. So increase in the production of what? This hormone, important hormone, which we call renin. Okay. Low blood pressure is going to make sure that the kidney starts producing what we call renin. And remember now, renin is going to do various important factors. Okay. So renin is going to make sure that it converts angiotensinogen. So what we simply means that renin is going to convert angiotensinogen to angiotensin 1. So here I'm just going to say angiotensin 1. So angiotensin 1. Okay, so I'll put it here, and your tensing 1. Okay, and it's provided by this renin. So let us go back again. So low BP causes the kidneys to start producing massive amount of renin, and renin will start now converting angiotensinogen into angiotensin 1. Okay, now angiotensin 1 will be converted into angiotensin 2. Angiotensin 2. Okay, angiotensin 2 by another hormone now, which is the ACE. Okay, so ACE stands for what? Angiotensin converting enzyme. So angiotensin converting enzyme basically is produced by the this one is produced, it's not produced by the renal system or the kidneys, produced by the lungs. So you need to take note of that. So after angiotensin 1 is being produced, then ACE is going to be produced by the lungs so that it can convert angiotensin into angiotensin 2. Okay, so angiotensin 2 now is the one that's going to have various important functions when it comes to low blood pressure. Okay, the first important thing is angiotensin, it has direct activities in the on the blood vessels. Okay, so it's going to make sure that these blood vessels, remember what we talked about in the first scenario here for norepinephrine and epinephrine. Also angiotensin 2, it has this effect, it can squeeze the blood vessels or constrict the blood vessels, and it becomes smaller. And if that happens, what do you think is going to happen? Okay, we're going to increase what? So we're going to write it here. We're going to increase the systemic vesicular resistance. Okay, if we increase the systemic vesicular resistance, what did we say? We're increasing the what? Blood pressure. Okay, we are increasing the blood pressure. So that's what happens when it comes to angiotensin 2. Okay, angiotensin 2 also has another effect. It will go to the adrenal cortex here. Okay, so these are adrenal glands. Okay, these are adrenal glands. So this angiotensin 2, apart from going to the blood vessels and constrict it so that it can increase the systemic vesicular resistance, thereby increasing the blood pressure. But here also it's going to make sure that the adrenal glands start producing aldosterone. Okay, so this aldosterone now will do something. So aldosterone will go to the kidneys. Okay, so let's just say aldosterone now here will go where? Will go to the kidneys. So aldosterone will go to the kidneys and stimulate the kidneys, so that now the kidneys can reabsorb more sodium and the water back into the bloodstream. Okay, so aldosterone, what are we saying? It causes what? If this is a blood vessel, okay, it causes now reabsorption of what? Sodium and what? Water back into the bloodstream. Okay, now if you are reabsorbing water and this sodium back into the bloodstream, what are you looking at? We are looking at the blood volume. So the blood volume is going to increase. If you increase the blood volume, alternative you are going to increase what we call the cardiac output. So if you increase the blood volume, basically the result of this, you are going to increase the cardiac output. Okay, so if you increase the cardiac output, now you are increasing the blood pressure. So as you can see now, everything that we are talking about, all these mechanisms, basically the end product is to increase the blood pressure. Okay, is to increase the blood pressure. Okay, so that since we had low blood pressure, but if this mechanism happens, they need to make sure that now blood pressure goes up, so that now it can go back to the normal ranges. And the other mechanism that the angiotensin 2 can do is to make sure that it will go to the hypothalamus and stimulate the production of what? Antidiuretic hormone. Antidiuretic hormone also is going to stimulate the reabsorption of water in the collecting duct. If you reabsorb water back into the bloodstream, what's going to happen? There will be increase in the plasma volume. If we increase the plasma volume, you are increasing the preload. The preload, now you are going to increase the cardiac output. Cardiac output increases the blood pressure. Okay, and the other important thing angiotensin 2 can do, it can go to the hypothalamus again and cause someone to now experience thirst, so that now they can drink more water and increase the plasma volume. Okay, so it does a lot of things. So now this system is what we call RAS. So if you hear the word RAS, make sure that you remember about this system. RAS. Okay, RAS stands for renin angiotensin aldosterone system. That's what we call RAS. Okay, so this system that I'm talking about, it is what we call RAS system. Okay, now in the next video we'll talk about how the body is going to regulate the blood pressure if it is high or increase above the normal range. Okay, so in this video we just talked about talking about how the body can regulate the blood pressure if it is low. These are the three important mechanisms that you can know. Okay, so now this is the end of the video. Make sure that you study more. Until next time.